Good evening, and welcome to Black Ham Radio Operators University. Excuse me, Black Ham Radio University. And today we coming to you with an exciting show. I'm very happy because I have a special guest, and you may recognize him from YouTube. He's what I call a YS, a YouTube sensation, and I got David KE0OG, aka known as the OG, and I also have Ash KK7GFG. Two great guests. They both wearing blue shirts. I don't have one back there, so I'm gonna just keep the black shirt on. Dave, you like black?
Black is wonderful,
All
although my
right, all
usual
right.
color is blue.
Ash,
So
you
I like black and blue.
Ash, you like black?
Well, I'm
Yeah.
wearing the same thing, black
Okay,
and
well,
blue.
look, I might sneak out and take a break and go sneak on a blue shirt so we can match. But anyway, hey, so before we get started, I just wanted Dave, I just wanted to make you feel comfortable with the show. I know you do YouTube shows all the time, so I just want to make you feel comfortable before we start. So, this is my contribution to making you feel comfortable before we start the show. All right, so yes. Welcome to the show. Was that good enough? Was that good enough, Dave?
Oh, my
Okay.
goodness.
Good. All right, so we're gonna get started. Dave, can you tell us how you got into ham radio and what inspired you?
Well, when I was in high school, I read a series of books they were the Tommy Rockford series, and they really made me interested in ham radio, but I couldn't find any kind of an Elmer or mentor. And so it wasn't until I got back to the United States in 1973, and the school I was going to, Brigham Young, had a very uh, active, welcoming ham club with lots of good equipment. And that's where I finally got hooked up with somebody who could teach me about it.
Okay.
That was back when you had to learn the Morse code. That was a struggle.
Gotcha. Do you think ham radio will continue to grow with the introduction of like new and improved technology in the future?
I think what will happen in ham radio, I think the biggest thing that could happen right now is the ARRL has proposed to the FCC that technicians be given voice privileges on HF. Because, in my opinion, the fun in ham radio starts when you're a general and you can get on the air and you're talking to people. You don't know where they are, they could be anywhere. Now, of course, you can do similar things with DMR and stuff like that.
Right.
The next piece of that is the youth. Um, I can't tell you how many times I've seen a bunch of old people sitting around talking about how we're going to get youth into amateur radio. I remember being at a convention where the league was there, and they were talking at the luncheon, how do we get youth into ham radio? And I stood up and I said, well, there's a forum, a youth forum, right after this meeting in this room. Why don't you go there and ask them? And they didn't. None of the league people came in and asked them. Um, my feeling is the thing that attracts youth to ham radio is youth in ham radio. It's one of those chicken and egg things. Um, think of it. When you were 16, did you want to go into a room of people with white hair who talked in a strange language and completely ignored you? No,
Nope.
of course.
No.
No, you wouldn't want to do that. You wouldn't want to do that. I was part of the Boulder Amateur Radio Club Youth Division, which was run by a retired kindergarten teacher. And she knew how to handle the youth. And we had at any given time about 30 youth. including my kids. And in fact, my wife went through that program too. And I was one of the Elmers. I helped teach. I was with that program for 10 years. And the youth want to talk to each other. They want to do the things that are fun to them. Boy, did they love Fox Hunts. And they did it every week on
Wow.
Saturday, every week. And that organization, Rip and Ellie, have both passed away, but that organization continues.
Wow. Okay. Wow.
Awesome.
Yeah. So
Awesome.
it's got to be youth oriented, youth led, and the old guys are around to answer questions.
Right.
And occasionally behind the scene, maybe pointing somebody in the right direction.
Makes
Okay.
sense.
I like it.
So how did you guys get into ham radio? You're both, well, let's see. Dree, I think you're a little on the younger side. You don't have as much white hair. I can see some on Ash.
Yeah. For me, I
I'll
just
be
oh, go ahead. Go ahead,
oh, sorry,
Ash.
Dre, go ahead.
No, for me it was just my father used to talk on the CB, and you know, I remember people knocking on the door saying you set my alarm off, my TV, and that was that. Then
Yeah.
I got back into walkie talkies back then, and
Yeah.
HTs, and just kept going and going as of recently. So I stepped out and came back in. So that's how I got pretty much
Excellent.
into it.
Well,
Okay.
good. How about you, Ash?
Well, I've always been a tinkerer. I just love to see how things work. So
Yeah.
since I was, God, 10, 12 years old, playing with Commodore 64 and looking at a radio and say, well, I hear the noise coming out of this thing. Where's it coming from? So just figuring out how things work, and got into shortwave and scanners. And I don't know how many scanners I have around here. Shortwave radios. And then in 1994, I got my first ham license. I was a technician plus. That was
Oh, plus, boy.
KD4KXO. And then
Wow, you
life
remember.
happens and it expired.
You remember.
And I
Wow.
came back. Yeah,
Yeah.
that was
Wow.
my name.
Right. Yeah. I hear you,
Oh,
man.
yeah.
But
Hey.
I just kept going with it, and
Yeah.
it's in my blood.
Hey,
Yeah.
yeah. Hey, Dave, what do you think is the biggest mistakes new hams make when they get their license and they get on the air?
Well, you just named one. They get their license and they don't get on the air.
Mm-hmm.
Okay. I would say out of the 800,000 hams that we have, probably 160,000 are active. And I think if you look at the statistics for who joins the league, they're almost all general and extra. There are very few techs. And so what I tell techs to do is, number one, join the league. Number two, find a club. And I tell them you may have to do a little bit of club shopping, because if you get east of the Mississippi, probably in any given area, there are several clubs. So do a little club shopping, find one that you kind of like, okay, kind of simpatico with the people. And then recognize that when you get on the air, you're going to be talking to the same people. So you want to get to know these people. It becomes a group type of thing. I guess the last thing I would say, and I say this all the time, is persevere. Don't give up. The first time you try something, it's flat just not going to work. And you've got to keep trying. You can't give up. You can get there. Now, I have the hardest time persuading people to join the league. They say it's expensive. Yeah, I filled up my Jeep the other day, and I paid more for that gasoline than it costs to belong to the league for a year. Okay, so don't give me this junk about the league being too expensive.
Right.
Second,
Right.
you're going to get a magazine every month that will help motivate you. I can't tell you how many times I've picked up QST, started going through it, and went, I want to try that. And then I'd go get on the air. So, and the other thing a new ham needs to understand is the importance of an Elmer, a mentor. It's just incredibly important. I've seen hams do other things too. I've seen several people who've gone 0 to extra in one sitting, and that's a really bad sign because that person is a great test taker. They've made their check mark, and now they're going to move on to other things. I know a ham who went 0 to extra in one sitting, and then I told him some basic gear to start out with to get used to being on HF. It turns out he wanted the top of the line everything. Tower, Yagi, the top of the line ICOM or whatever it was. And that's like trying to learn to fly by stepping into the left seat of a 747. And, I actually put together a reference station. If you go to dcasler.com/reference, it's got a list. These are all the things you need for a general station. And here's the specific parts to buy. And if you buy these things, they'll work. You'll have a great station. Probably the first thing you'll replace is the antenna, but it is a reference. So, for example, if you want a Yaesu radio rather than the ICOM, sure, go ahead and swap in and out. But they got someplace to start. I got to tell you, the question I am asked the most often is which HF radio should I buy?
Yeah.
And I used to say, well, that's a highly personal thing.
Yeah.
Now I tell them it's the ICOM 7300. Go get one and get on the air. So,
Yeah, pretty much, right?
Make it simple.
That was my first radio, and I like it. I think the learning curve on it is pretty good. Watching a couple of your videos and a couple other videos, and you just get it just like that. So
I'm going to show my age here, and my first HF radio was Drake TR4C.
All right.
And it's back there in the corner. I don't use it anymore, but
great radios.
Oh, I love that thing.
I learned.
I had
Do you still have it?
Yeah, it's right back here.
Oh, okay. Do you use it at all?
No, I don't. It's already warm up here because there's so much stuff on.
Oh, gotcha. Yeah.
I don't need any more heat in the room.
Yeah, that's true.
Yeah.
So let me ask you, let's get to some antennas here. And I know you probably get this all the time, but in your opinion, this is just your opinion, so there's no right or wrong answer. And I don't like when people ask me, I think I hear some echo. I don't like when people ask me, not everybody asks me because I'm new myself, but there's a few. What antenna should I get? That's like asking, when people ask me that, it's like asking me, hey, which woman should I marry? I don't know. What do you prefer?
The right one.
Yeah.
The right one.
What's best for you? So
whichever one works.
Exactly. So whatever. In your opinion, what's a good antenna for a new ham if they have small space, maybe height restrictions and like little yard space, and if they have what do you call it? An HOA. Like
HOA. Love HOAs.
Oh, me too. I hear you, Dave. Yeah.
Which antenna manufacturer is going to advertise in QST? Is it going to be the really inexpensive antennas, or is it going to be the really expensive antennas?
Wow.
It's going to be the expensive antennas. Look, you turn the page to the first page in here, and it's an MFJ ad for Cushcraft. And these radios here, the MA6B6, let's find one that's a vertical. The Cushcraft R9 for only $889.95. And do you know what? That's a vertical.
Wow.
It's not going to perform any better than a dipole. So in my list on the reference station, the very first antenna that I think a ham should have on HF is a dipole.
Mm-hmm.
Yes,
You make it
Okay.
yourself.
Yeah.
that's
And
right.
you can make, and the one that I reference is actually one that's from MFJ. It's the 2010. It costs, I think, $89. Okay, so it's going to be buried down in the small fine print in the MFJ ad. But it puts you on 40 and 20, and it gives you all of those bands. It doesn't just give you a part of the band, it gives you all of those bands. It's also good on 10 and 6, which are opening up right now. But
Right.
what an easy way to get on the air. Now, you ask about small space, and this is a real problem. There are a number of verticals like that R9 that don't need radios.
Mm-hmm.
Okay, so do you want to pay $900 so that you don't have to spread a little wire out? Let's suppose you've got a yard that's 20 foot square.
Mm-hmm.
That's not very big. That might be something you'd find, when you get kind of out in the suburbs or something. You got a little
Yeah.
backyard. Um, DX Commander, their classic antenna, it's plastic. Granted, it's plastic, but it works. I had a little quarrel with them over their instructions, and they've since greatly improved their instructions. I tried to find a very smart high school kid and see if he could follow their instructions, and he couldn't do it. He couldn't do it. And so I got another really smart high school kid to try with the next version of the instructions, and he was able to pull it off. Granted, it collapsed on him the first time he put it up.
Oh.
We figured that out. He put 10-foot radials on that thing. That'll fit in a 20 by 20 backyard. And it's a vertical antenna. It'll take you 40 through 10, maybe 6. And it's relatively inexpensive, 350, something like that. But there's this thing that people think about radials that, oh, I got to have 10 million of them and they each need to be a mile long. No, just no. Throw down some radials and get on the air. So,
Wow.
and here's the thing: a vertical, even if it costs $900, is not going to perform any better than a dipole.
Awesome.
Wow.
They're the same.
Yeah.
Why,
Let me.
That's good stuff.
why not make your own dipole? You can do that. I have a
Oh,
video
yeah.
on how you go down to Murdoch's and get some electric fence insulators, go down to Home Depot and buy some wire
Yeah.
and get an SO239 and solder it in, and lo and behold, you've got a dipole.
Yeah,
Yeah.
my parents were not happy. What is all this wire in the backyard? And what are you putting on my attic, on my chimney? What is that
Yeah.
thing? So eventually they figured it out. They've got a pretty techie son. So that's how I learned. You put it up.
Well,
If it
that's
don't work, take it down, figure it out.
and
Yeah.
you persevered, didn't you? You didn't sulk in a corner when your parents told you to take it down. You got up
I
there
just
with a
found enough.
stick.
They were my HOA at the time.
Oh,
Let me.
yeah, a lot of wives fulfill
Yeah.
that.
Let me ask you this. Why is the wire length of an antenna, why does it vary depending on the frequency?
Well, antennas are funny things. When we go through the technician book, we learn about Ohm's law. There's current, there's voltage, there's power. But the problem is that when you get into RF, dealing with radio frequencies, all that kind of goes out the window. You have to start dealing with electromagnetic field theory, which is not talked about in the technician book. You get a little of it in the general and a little more in the extra. And I got a lot more in my double E graduate program. But the thing is, you got to look at this. Radio waves go as fast as the speed of light because light is a special form of radio wave. They all go at the speed of light, which is doggone fast. But if you've got something that's at a low frequency, each wavelength of that gets longer and longer and longer because in order to travel the speed of light, you've got to do a certain number of oscillations to get there. And if it's only, say, 4 megahertz, each one of those undulations is 75 meters, no, twice that, 150 meters long. No, 75 meters long. I've got my brain, not all parts of my brain connect anymore. So if you go up in frequency, well, that thing's wiggling a lot more. And so in order to go the same distance in the same time, each wave has to be shorter. Otherwise, they'd overshoot.
Mm-hmm.
So as you go up in frequency, it turns out that a piece of wire, a dipole, half wavelength long, has special properties in electromagnetic field theory. It acts, and this is the wild part, this will blow you away. It acts as a transformer between the 50 ohm transmission line and the impedance of free space, which is 377 ohms. And once you do that, the energy was never in the wires in the transmission line to begin with. The energy in a coax cable travels in the dielectric.
Mm-hmm.
Now, the other things have to be there to make things work. But once it gets to the antenna, it can spread out. That's the beauty of a dipole. It is just about, not every, just about every antenna is some complexification of a dipole.
That's true. Yep.
Yeah.
Okay.
And, you know, Yagis, you add more elements. Okay. You can make it into a loop. You just bring the ends of the dipole around. You can do all kinds of fun things like that. But somewhere in there, there's a dipole.
Yeah.
And so as frequency goes up, remember the wave can only go so far in a second. And if it's vibrating very slowly, it's got to really scoot along. And so it's got these real long vibrations.
Mm-hmm.
But if it's got a lot of vibrations and it's going to go the same distance, each one can be shorter.
Awesome.
So
Gotcha.
constant
That kind
and
of
all of it.
brings into the next question is antenna tuners. How
Mhm.
does that really play into having the right length antenna? Or if I don't have a lot of room, if I have just a shorter dipole, or can I just throw a piece of wire out of the window? Would that work at all if I had an antenna tuner?
Well, the answer is yes, absolutely. In fact, all of the major Japanese manufacturers make a tuner that you can put outside, designed specifically to feed a random length of wire. And they view that, since, you know, Japan's really crowded, you would be really lucky to have a 20-foot square backyard. So they just string up random wires there, and then they have a tuner that will tune it. Here's the secret. An antenna has to be resonant, okay? Meaning that it's like when you push on a swing, you know, with your kid, you push at a certain interval. If you don't push at that interval, the swing suddenly stops. And your kid wonders what's going on. How come my dad doesn't know how to push a swing? And so you've got to be resonant somehow. Now, resonance comes from capacitance and inductance. And when the inductive reactance and the capacitive reactance match each other, you've got a nice resonant antenna. Now, let's suppose you're too short. An antenna that's too short is capacitive. So what do? You either add a loading coil to it, which adds inductance so that you can make up for the inductance the rest of it doesn't have. Or you can put a tuner there, and the tuner, when it tunes, will add the necessary inductance
Mm.
and make that antenna sing. And it works the other way too. So if you've
Awesome.
got an antenna that's capacitive, you add a little inductance in the tuner, and vice versa. If you have an antenna that's too long, you add a little capacitance in the tuner. And your tuner, all modern tuners are T designs. So you have two capacitors and a variable inductor.
Awesome. And for the record, for everybody watching, I do know what an antenna tuner does. But I
Yes.
ask the questions because to educate.
Yeah, absolutely. Absolutely. So,
Yeah, antenna tuner makes your radio much happier.
yeah. Yeah. Let me ask you this. This is a question that came when I posted some promo about you coming on the show. I asked people to
Sure.
ask me some questions. One person said, I got it written down here. It says, what's the difference between an un and a balun?
Oh,
And it says, can you explain the purpose of each?
okay. First of all, you have to talk about balanced and unbalanced, and no, that's not a mental health question. So, take a coax. A coax, the shield is at ground potential. And you've got that center wire in there, and the RF is coming back and forth, back and forth, back and forth, affecting the voltage on the center conductor while the outside remains grounded. It's a very common way of moving information in today's technological society. And that's called unbalanced because only one wire does all the work. It pushes, it pulls, it pushes, it pulls, and the outside doesn't do anything. It's at ground potential. Now, your standard dipole antenna is fed in the middle. And whatever this half does, the other half is doing the opposite. And the center point of all those gyrations is in the middle. That antenna is balanced because it's like yin yang. When this does yang, this does yang. Okay. They're opposite each other. So if you take open wire line or ladder line or something like that, two parallel wires, one pushes while the other pulls, and they go back and forth and back and forth and back and forth. Now, the problem with that, well, there are a lot of advantages to that. Sometimes you actually do want to use window line or ladder line. But the electric field doesn't have a neat little pipe to go through. The electric field surrounds the open wire line. So that's why you have to keep the open wire line away from everything else. You have to use little spacers to keep it away from the walls of the house and going up the tower or whatever it is, because that little tiny bunch of wire that's going along like this wants like that much room around it to move the electric field. So open wire line has some advantages. It's a lot, and by lot I mean tremendously less lossy than coax. So if you're going to send a signal a long ways, open wire line is the way to do it. Or you can get really expensive coax like times microwave and stuff like that. The bigger the coax, the less the loss. But then that raises the price too. My favorite all-round coax is RG8X. It's handy. It's easy to manage. You can put connectors on it fairly easily. It's easy to route around things and not terribly visible from a distance. And I use RG8X for almost everything, except outside, from the lightning arrestor, to the hex beam is RG213. From the lightning arrestor to the antenna I've currently got, the vertical is some Italian stuff that somebody brought me. And then the one that goes up to there's LMR 240. I'm sorry, LMR 400 in there somewhere. In other words, I love whatever coax I have at hand.
Whatever you have, right?
Yeah, that's right.
Yeah, yeah. Let me ask you this. There's another question that came also. They wanted to know the difference between, I guess, because the numbers, they got confused with the numbers, half wave and quarter wave. What is it? What the
Oh.
measurements?
You know, I didn't actually answer your last question. And a balun is something that converts unbalanced to balanced.
Okay.
Okay. And an unun, which is used like an end-fed half-wave antennas, takes an unbalanced line, and there's an unbalanced line going out, but it's at a very different impedance. Okay.
Got you.
So it's just an impedance change, one
Okay.
to the other. Now, you ask about half-wave. Nature is weird. The idea of a half-wave antenna keeps coming up over and over again in nature. If you look at an organ pipe is a half-wave resonator, and it will vibrate at its fundamental frequency. And actually, it's a 2-foot organ pipe that vibrates at middle C. So you double that to 4 foot, you're down 1 octave below that. To 8 foot, you're down 2 octaves below that. So, and the 8-foot pipes are longer for the lower frequencies, just like electronically. But they're half-wave resonators, and that's in mechanical things. It has nothing to do with electronics, but it's the half-wave that resonates. And we see that over and over in all different kinds of things that nature does.
Yeah.
So the half wave is the dipole. You put up a half wave dipole and you feed it properly, and it will resonate and radiate very well. Now, if you say, well, now, wait a minute, why can't I just put 2 of those together and have a full wave? And the answer is, if you take a half wave dipole and you add another half-wave dipole at the end, yeah, that'll work if you feed it in the middle of the first one. But if you try and feed it in the middle of the 2 half-waves, it does not work. It just doesn't work. Nature doesn't work that way. So now, a thing a lot of people don't understand about a dipole is that a dipole is a dipole is a dipole regardless of how it's fed. There are center-fed dipoles, off-center-fed dipoles, end-fed dipoles. They're all dipoles. They all act the same. They're dipoles. So your basic antenna is a half wave. Now, if you turn that up like this, okay, so that you're vertical, you've got a vertical antenna that's a half wave and you feed it in the middle. And yes, you can do that. That's a legitimate antenna. But what would happen if we take the bottom element of that, split it into 16 pieces vertically, and laid them out flat in a radial field? That antenna will work the same.
Okay.
And the radial field acts as a reflector. I did this in one of my videos. I took a pen and put it on a mirror, and you could see the other half of the dipole down in the mirror. And that's how a vertical works. So you only need a quarter wave. But if you only have a quarter wave, you're going to have those radials out there to make the other half.
Right.
Now, if you make it a half-wave dipole electrically, you can electrically shorten it by adding capacitance and inductance.
Gotcha.
And you end feed it. It's the same as an end-fed dipole, except turned vertically.
Right.
My favorite antenna.
But
yeah.
The dipole?
No, in-fed half wave.
Oh, the in-fed half, yeah. That was
2 of them.
that was my first. That was my first antenna, and it's still my first because I never got a second one. I'm actually going to make an antenna. I've been doing a video and kind of keeping track of doing a video so everybody can walk with me through this journey of doing it. So it's been a real slow process.
Yeah.
But my thing is that this is a question that popped up. I think it was a question I was going to ask. Is there any effect on antennas being too close? Like,
Oh yeah.
And what's the distance as far as like how close can they be before it starts getting a little rocky?
The secret to antennas is that everything affects everything. If you've got two antennas at different frequencies, like an 80-meter dipole and a 20-meter dipole, they're not going to affect each other much at all. So you can actually create a fan dipole, feed it at the same point, an 80-meter dipole, 40-meter, 20-meter, so on. And only the one that is resonant at the RF frequency will become operative. All the others are just hanging there, useless metal in the air. So you can make fan dipoles fairly easily. Tell me the question again. I'm an old man. I'm sorry. You got
is it
help me.
how close can an antenna be?
How close they be? If they are both for the same frequency, like two verticals, each 40 meters, and you're going to use one but not the other, well, the other becomes, it's like a Yagi. You've got a driven element and you've got a reflector. And it's going to push the signal in that direction. Okay, you can put both antennas up and feed them the same so that they radiate the same, and you'll have nulls and you'll have areas where you get extra signal.
Got you. Now,
and you can actually repeat that with as many other driven elements as you want. You can actually steer the beam by varying the phasing a little bit.
Right. What about one end-fed going north and west and another end-fed, same antenna, one end-fed going north and west and one going did I say north and west? Wow. North and south and one going east and west. Is that an advantage, or is that something like I might as it's not worth it?
Well, I mean, it's hard to say that any antenna playing around with antennas is not worth it. But I would say that this business of dipoles being directional is overrated. First of all, for a dipole to radiate properly, it needs to be at a half wavelength. Well, for 40 meters, that means it has to be up 66 feet. How many people can do that? Not very many.
Not too many.
I can't.
Yeah.
So they're going to be non-optimal. And the more non-optimal they are as far as the height, the more circular the radiation pattern is. So, yeah, it's true. Off to the side, you get a little bit more like a half S unit maybe, and maybe a half unit less on the other ends or something like that. But if you're operating, I mean, geez, the QSB of the moment is already doing that to the signal you're trying to hear. So I think the directionality of a dipole should be what works best for you.
Got you.
Right.
So I want to switch it up a little bit because here's a big one. Here comes the big bang right here, and this is just a loaded question, and it's so bless you. There's so many different answers to this question. There's so many variables, but let me tell you about SWR. Let me ask you about SWR. I set up my radio. Everything's working fine. I was on 10 meters. I was knocking on more doors than a pizza man delivering pizza. And all of a sudden, after a month, the SWR shot up like a bottle rocket on fire on 4th of July. I mean, just boom. Out of the blue, I did nothing. I thought maybe one of these birds out here kind of ate at the wire. No, nothing like that. But it just shot up. Now, here's the loaded question. What, I guess you can give me the top three things that can cause that, because I'm pretty sure there's like 1,000 things that can cause it. But what are like the top three things that could be it?
Well, the top two things would be somewhere there's an open circuit.
Mm.
Something pulled out of something. Something broke in the coax. The coax, sometimes the braid will pull out and you don't have contact with the braid or something like that. The other thing that can happen is if something shorts. And, like the coax gets twisted and it pulls out the braid and it contacts the center conductor. So the first thing to do is to check your coax. And probably the best way to do that, although it can be a little bit of a pain, disconnect the coax from the antenna, okay, and connect it to a dummy load, and then go inside and see what your SWR is. If it's 1-to-1, the coax is okay. Now, it could be something on the antenna that fell off, got loosened and slipped down. I mean, the problem with aluminum, we all use aluminum antennas, right?
Mhm.
If it's a vertical. Copper's too expensive and not as strong. But aluminum, as it sits there, it oxidizes a little more and a little more and a little more, and that's fine. But every so often, you need to go retighten all those connectors because as the wind comes by, they will vibrate them loose. I had a butternut HF9V that got really bad like this, and I thought it was just a bad antenna. And so one summer I rebuilt it. I mean, I stripped it down to the last screw. I replaced a broken capacitor, which was $100, and did everything and put it up. And my wife and I very, very, very carefully tuned it, and it was a great performer. It really was. In fact, I had a great big 80-meter loop at the time, and I actually took that down, cut it up into more radials for the vertical. So it's just that one day the wind blew in this direction just a little too much, and you need to go tighten something on that antenna.
Okay.
Now, there are other reasons for antennas to go south. If you've got a balun in there, and the balun has a magnetic core, a toroid in there. If you get that toroid hot because you're putting too much power through it, or a lot of power for a long period of time, it'll heat up. And when it heats up, it changes its magnetic properties, and your SWR is going to go out the window.
Right.
The other thing that can happen is you can actually shatter the core.
Wow.
And this could happen because of a nearby lightning strike, could put enough through it to cause it to shatter. Something like that. So check for something mechanical.
Okay.
In there is probably what's going on.
Let me ask you this: is some people say 3-to-1 is acceptable? SWR 3-to-1, 2-to-1. Is that acceptable? Well, if let's just say 3-to-1 is acceptable, you like to get it lower, but 3-to-1 is acceptable. Does that damage your radio in the long run?
If you don't use your tuner, yes, it will.
Okay.
But all the modern radios come with built-in tuners that will handle SWR up to 3.
Okay.
Now, which is not really very much, but that's actually a fairly significant amount of power that's sent back. Your antenna tuner is going to capture that and throw it back at the antenna. And it's going to go back and forth and back and forth and back and forth, causing the line, the coax, to heat up. And you're going to lose power to heat in the coax. Coax is so long you don't notice it in a little piece, but it's there.
Right.
Now, acceptable SWRs. First of all, if you put up a dipole, no matter how hard you try to tune it, you're not going to get an SWR any better than about 1.6 to 1. The reason for that is because it's almost impossible to get an antenna tuned to understand here. The frequency of resonance is when there's no reactance, but that may not be your lowest SWR because the center feed point impedance depends on the altitude in the air. And if it's only up 20 feet or so, the center point impedance is like 30 ohms. Even if it's completely resistive, it's 30 ohms. You're 20 ohms off. Okay, so you're going to get about a 1.6 to 1. Now you could tune that out in your radio. And what the radio will do is fool the radio. The tuner will fool the radio into thinking it's 50 ohms. Now, I would say that if you've got 2 to 1 SWR, you're okay on either, at the edges of the band or something like that. Your tuner can take it out. Anything beyond that, and I think you ought to look at your antenna and see if you can do a little better. And maybe check your ground system, see if you can do a little better there. But 3 to 1 in the tuner will tell you if it can't match. But if you're doing like I am, I don't have a high power tuner, but I do have an amplifier right there. So I have to make sure that all my antennas are kind of under about 1.6 to 1 in order for that amplifier to feed it properly.
Gotcha.
Now, understand that SWR is not the be-all, end-all of antennas. The only reason that we talk about it so much is because it's easy to measure.
Yeah. Okay.
Well, let me ask you this. I know we were speaking about, and I'm not going to keep you long, but get you out of here in a couple more questions. As far as the SWR going up, I was told to check the connections. I want to go to this diagram here. This right here, this is one of the cheaper ones. So, one of the cheaper ones, but this 7-function digital meter, when you're testing the coax, because I myself got a little confused. What goes where on what when you're testing it, and what the number that I got for that meter was just weird. I don't even remember what it was, but that meter was just like, it was like 0.60 or something. I don't know, but it was just crazy. What is the number? What number should that be when you're testing the coax, when you're putting it on the actual the ring of it and inside of it?
Okay, there are a number of ways, and I always make these first tests when I put connectors on coax. The tip to the ring should be infinite impedance.
It's not
okay, there should be no connection between the center and the outside of the coax.
Okay.
So it should be in the megohms or higher. Okay. Now, tip to tip should be as close to 0 ohms as you can get, but you are dealing with real wire here. So it could be 1 or 2 ohms. And the same with shield to shield. Now, another thing that I check, tip to shield on both of them. Make sure you measure both of them in case this tip down here isn't actually connected. You should have nothing touching between and very good conductance for shield all the way around and for tip all the way around. And that's a Harbor Freight $6 multi.
Cheap.
And the thing about the Harbor Freight, people say it does not properly measure AC RMS. And I was thinking to myself a few months back, when was the last time I wanted to measure RMS with a multimeter? And I couldn't think of a time. Now I can see it on the O-scope, but on a multimeter, if I want to know what I can be doing, put it on the O-scope and take a look.
Right.
So that Harbor Freight meter is your friend.
Okay. All right. All right. I'm gonna get you out of here on this last question. I try to ask this last question to everybody that comes on. What's your favorite antenna? That was a real simple question. Your favorite antenna?
Oh, this is a good one.
Here it comes. Now, everybody's gonna go out and buy this thing, but just be. I'm just
Everybody's
letting you know.
about to write it down so they can go buy one. We should check the stock.
Well, I have several antennas. I have two antennas I consider permanent or kind of permanent. One is an MFJ hex beam,
Mhm.
and that works really well. It just is a great antenna. But the problem with the hex beams, you got to point it. So if you got a signal coming in the side of it, you're not going to hear it,
Right.
you know. So the other antenna I really like, and this, if you got 3 hours for the story, I could tell you, but it's a step IR big IR. It's a vertical. And it's a kind of a premium vertical. I know a vertical is a vertical is a vertical, but this one happens to work really well. It's very reliable. The instance of it is, I mean, it's well anchored. It's got a ground rod. It's got like 36 radials, the various distances. That thing just performs like a champ. And that's my reference antenna for testing other verticals and things like that. Like I just bought using channel funds a Wolf River Coils TIA, Take It Along, and I'm halfway through testing it, and it's a tiny little thing. And this is one of the things that I think a lot of people don't realize. If you have a vertical that is a full quarter wavelength high, great. But if you have something that's only 10 feet high, but it has a good loading coil and a good ground and some radials, you'll get out just as well. Now, there's a compromise there, obviously, and the compromise is bandwidth. You won't be able to cover the whole band with that one antenna.
Gotcha.
So I guess my favorite antenna is whichever one I feel like using at the moment.
All right, that
Great
makes
answer.
sense. That makes sense.
Is that good enough working around the question there?
That makes sense. All right. Hey, well, David, hey, thank you for coming on the show. We're going to end it now, and hey, I appreciate you taking the time. It's definitely been an honor to have you on here and get all this information. The good thing about it is that this is being recorded, and those who are watching it or didn't get a chance to watch it can go on YouTube and review it. And, you know, just or Black Ham Radio University Facebook group, and you can watch this video over and over again and use it as a reference to either building an antenna or whatever you want to do. So thank you. I appreciate you coming on. I'm gonna say goodbye to the the audience, the watchers, and Dave, I just want you to stay on once we log off here real quick.
Okay, very good. And
everybody.
All right. 73.
73.
All right. I say that on the phone sometimes. I need to stop. 73, everybody. Thank you for watching. We appreciate you, and have a great night. Good night.
Have a good night.